How's it going? My name is Charlie Kepler. I'm a flight engineer here at Headwall Photonics, and we're going to go into how to build a flight plan with UgCS. So first, we're going to open up the application. If you don't have the application installed, you can go to their website and download the latest version. If you're using UgCS Pro, which is version 3.3.438 at this time, July 2nd, 2019. First thing you'll see is a zoomed out version of the globe, and you can search for a place with a latitude and longitude or an address or some other form of coordinate. So I'll type in Bolton, Massachusetts, which is where we're located. I'm using right now the mouse wheel to scroll in and out, a left click to drag, and then a right click to change my orientation. If I look down here, there's a compass which I can click to orient myself north-south. And if I zoom in, right next to the highway, here we are at Bolton Office Park. So the first thing you're going to want to do is go to Menu, and then Main Menu. And if you haven't already done so, you want to import your license. Your key that you are given is good for 2 seats, so you can put it on your field computer and then your lab computer, or if you have 2 users, you can put it on each of those. The good thing about this software is you can activate and deactivate as needed, so if you have 3 or 4 people who will be using this, you can activate just so as long as you're only having 2 seats activated at one time. First thing we're going to do now is go to payloads. We're going to create a new one. You're going to fill in all these values with these numbers. The only one that may change is this true focal length value. Instead of an 8, you'll want to put in whatever focal length lens that you are using. Otherwise, all the other values should be the same if you're using a nano hyperspec. Once you're done with that, save it, and we're going to go to Profiles. Look over here for the DJI Matrix 600. Click on it and say Edit. You go down here and Add, and then you're going to find that profile or that payload that you just created and select it and add it in. You'll only have to do this once. I have a whole bunch in here because I have a bunch of different configurations. But since you most likely will only have 1 or 2, you only have to do it for the 1 or 2 if you have multiple lenses. Click Save when you're done. The other thing in here that is good to note is there's a whole bunch of settings that you can look into. I would advise you not to change any of these unless you have a specific reason to. For example, here the fence radius, I have upped it to 4,000 meters because it's defaulted at 500, and one time I wanted to fly further away than 500 meters, so I know that safely I can fly up to 4 kilometers away. Even though I may not actually fly that far away, I changed this just so that I would be able to fly a little bit more than half a kilometer. But I would advise not to change any of these settings unless you have a specific reason to, and you know that it is safe to do so. Click Save when you're done. Now we're going to go hit this back button. And now we're ready to begin actually planning the flight. So first we're going to click this Add New Route button. And we're going to create from scratch. Click Next. Give it a unique name. And then you're going to select the profile that you edited before, so the DJI Matrix 600. Since I last used it, it's at the top here, but otherwise you could scroll down and find it. Click Next. We're going to set the maximum altitude above ground to 120 meters, because that's the legal limit in the US. We're going to check that our emergency return altitude is a safe height for where you're flying. Here at Headwall, I know that the tallest tree or power line or building is not higher than 40 or 45 meters, so I set it to 50 because I know that in an emergency, if it returns home at 50 meters, it will not run into anything. All the other things we want to keep at the defaults. Click OK. Now this toolbar pops up on the left side. We're going to begin with the photogrammetry tool. And you're going to start by double-clicking to place 4 points or whatever size polygon on the ground that you want to create. Once you're finished, you're going to drop one last one and then drag and drop to your first point to close the loop. So first thing I'm going to do here is click this trash can to remove the action. Since we're a line scanning imager and the UAV and the sensor aren't talking to each other, we don't use anything that refers to actions, so we can disable this. Here it says the camera is not facing down, and it's kind of throwing a warning. That's okay, because again, since the UAV and the camera aren't actually speaking to each other, it doesn't know really what's going on, so it's kind of confused, but we can ignore this for now. So we're going to start from the top. You can put in a specific latitude and longitude for each point if you would like. Right now you see this one is a little bit orange, and these three are yellow, so the orange one is the one that that's the coordinate of this point. If you wanted to say place it at an exact point, you could change the latitude and longitude so that it would move to the corner of a field or the parking lot or something like that. And if you want to change which point you're referring to, you can click these arrows. First thing is flight speed. For planning, I usually set this at 1 meter a second for now. That's the only parameter that we can't really determine ahead of time because it depends on the lighting conditions when we're actually doing the flight. The drone will not take in a speed less than 1 meter per second, so I set at 1 while I'm doing my planning because I know that's the worst case scenario. Turn type, this is one of the things that we really like about this UgCS software, is it allows us to do this adaptive bank turn. So we always want to use that option. The reason being, when doing any sharp turns on the axis of the drone, the GPS will get kind of confused. So it has a Kalman filter inside of it, which means that it basically uses the previous position to predict where it's about to be. And so if you do a quick turn on its axis, like the stop and turn option, the GPS thinks that you're going to be continuing straight, and then all of a sudden you make a 90-degree turn and it gets confused for some amount of time. So with the adaptive bank, it kind of does a nice slowly rounded turn to do a turnaround. Next, camera. If you only added that one payload, there should only be one option here. Since I have a whole bunch, I can choose which one I want to work with. Today we'll work with the 12mm Nano. Next one is GSD, or ground sampling distance, which is essentially the resolution. So how the photogrammetry tool works is you specify what resolution you would like, and then it tells you with your parameters how high to fly. So in this example, 1.85 centimeters is the size of our pixel, and if we hover over, it tells us that gives us an AGL altitude of 30 meters. Forward overlap we set to the minimum amount, which is 1, because we do not use any forward overlap, but it needs a value, so we set it to 1. Side overlap we do care about, so we set that to 40 because we found that's an acceptable value to give us enough overlap without being overkill. We want to just make sure that we're not going to miss anything if there's a gust of wind or something that rolls or pitches the aircraft. So 40 seems to be an adequate value. Camera top facing forward we want checked. Direction angle, this is degrees from north-south. So if I change this to 0, you'll see how the flight lines change. And now these are oriented north-south. So you want to fill the box with as few flight lines as possible because that's the most efficient. So for this example, we found 214 degrees is a good amount. You also can always move around your square or your polygon to make it bigger or to fit wherever you would like. This green check mark means that it is done calculating. You see if I make a change, goes yellow for a second, and then it starts to spin, and then once it's green, that means it's done thinking. You also can click on this middle section and drag the whole route around, or if you click the outside, you can change the angle. Continuing on, the next one is avoid obstacles. I leave this checked even though there actually isn't any obstacle or collision avoidance built into the DJI M600 Pro. You have the option of importing your own obstacles into this flight planning software, which we don't typically use. I would recommend, instead of importing any obstacles, to physically just go to the scene ahead of time and verify that yes, that power line is this tall, and I will plan so that I'm either above it or not going to interfere with it. But just to be safe, I always leave this checked. Action execution, again, we're not using any actions, so that can more or less be ignored. I just leave it at start for now. Additional waypoints adds extra waypoints in between, and as you can see, it adds a whole bunch, and since the limit of how many waypoints the drone can take in is 99, this is not reasonable, so I don't recommend using that feature. Next one is overshoot. You can see I have 20 meters in here, and the flight plan goes 20 meters past where my box is to turn around. We recommend using 10 to 20 meters of overshoot so that you exit your collection area and then have enough time to turn around, and such that you're going back and you're straight by the time you enter your polygon again. Overshoot speed, if you leave it at 0 or blank, it'll take in the flight speed of the aircraft. We recommend to keep it at that so that it's the most efficient and you're not speeding up or slowing down during the turns, because that just wastes energy. Altitude type, you always should be using AGL. The two options are AGL or AMSL. UgCS has the ability to follow terrain. It has a built-in DEM, or you can actually import your own DEM if you have a higher quality or a better one. But we always want to be following the terrain, because that'll change the size of our pixels, and so we want to remain a constant height above the ground. Allow partial calculation. If you have built a flight plan that is longer than 99 waypoints or is really big, you can click this button to allow partial calculation, which means you could only upload the first bit of the flight plan, and then you could come back and then upload the second half of it for your second flight to do the whole area. AGL tolerance is defaulted to 3 meters. This is how closely it tries to follow that terrain model. So what I recommend is leave it at 3, and then if you have extra waypoints to give, so in this example, if I hover over here, it tells me total number of waypoints 24. So if you're not pushing that 99 waypoint limit, I would then work on minimizing this down to 0 if you can, or somewhere in between. And you see now, before it was just flat, where here now it added in waypoints where it tells that the ground is a little bit different in altitude. And that makes sense, because right around here is a slight berm. So it added some points in so that it more accurately follows the terrain. No actions at last point. Again, we're not using actions, so we can ignore this checkbox. Double grid, if we check this, it basically doubles the flight plan in the opposite direction. For hyperspectral, this is not really a good idea. It just adds extra data and extra time that is not really necessary, so we can ignore that as well. So once you're happy with this portion, we're going to want to click this modifier insert new route segment before the current one button, and then now we're going to use this waypoint tool. And what this is going to do is it's going to input a single section before this route, and so this is basically where we're going to take off from. So I'm going to add this in by double clicking. Drops a point in, and so now this is our first waypoint. It's going to fly here, and then fly here, and then begin the route. The reason we need to do this is DJI has a safety feature that will not allow you to upload a route unless your takeoff position is within 30 meters of your first waypoint. So since we're taking off around here, this is further than 30 meters. As you can see, it's about 34 to 39 meters away, and so just to be safe, I'll put this in so that it flies here and then flies here. If you would like, you can do that at the end as well. Right now it's going to stop at this point. If I wanted, I can just add in another waypoint. So you're going to mouse over to this next segment button, and you're going to go to the end of your photogrammetry tool. So you're on segment 2 of 2, and now we're going to click this waypoint tool, and then we're going to double click over here again. That's going to add in this end segment, so now instead of ending over here, it's going to fly back closer to where you took off. The waypoint tool, the altitude is set by AGL, so in this case, if we look down, my flight altitude is at 30 meters, but my first and last waypoints are at 50, so I probably want to keep those at the same height, so I'm going to change those to 30. The other thing that you can do here is, since you're not collecting any hyperspectral data over these short portions, is you could speed up the aircraft to maybe 5 meters a second so that you're using less time going slow. And also, same thing, we want to make these adaptive bank. So now that I have my flight plan built, I'm going to want to click this Add New Route button again. Again, we're going to create from scratch, or if you want, you can import from file. We're going to create our area of interest or our polygon for our hyperspectral sensor. So if you have a KML or other file, you can import that here, but we're going to just quickly create one from scratch right now. Label it polygon, and then even though we're not going to actually use this as a flight plan, we're still going to just click this dGeometry 600 and say next for now. And then say OK. This time, we're going to use this perimeter tool. And same thing like the photogrammetry, we're going to double click to drop 4 points. And then the fifth one we're going to drag and drop. And you see it just creates an outer limit of this polygon. We're going to drag it so that we're intersecting with our area of interest as defined by our first box. Once we're happy with this, notice we're going to fly into this box straight. We're going to collect data from here until here, and then we exit straight, execute our turn, fly straight, enter the box straight, and then we'll collect data through here as well. And then same thing, we'll execute our turns outside. We want to have a little bit of buffer on either side, just because the GPS of the drone itself is not a high quality GPS, and so you tell it to fly right here, but it could be a meter this way or a foot this way or whatever it is. It may not be exactly right on this line. It'll be pretty close, but not perfect, and so you don't want it to be right up against the line, because if it is over this way a little bit, you'll miss that last line. So we want to give ourselves a little bit of a buffer on either side. When you're moving these points around, you want to make sure that it's highlighted and you see the 4 arrows pop up. And then when you're happy with your polygon, we're going to go to this parameters button, and then we're going to export to KML. Give it a name, browse to a location, and then click Save. So a couple other things we want to check. If we go to the parameters here, we have this tool called Show Elevation. This is a handy tool because it'll tell you at 1 meter a second over this area, it'll take you 16 minutes and 17 seconds to complete this flight plan. We know that we can fly somewhere usually between 15 to 20 minutes, depending on a variety of conditions and altitudes and where you're located at. But in general, 15 to 20 minutes is kind of what you can expect, so I say 16 minutes is probably pretty reasonable. And you can also check that, yeah, my waypoint count is 32, so I'm not above 99. So since I say, okay, this is acceptable, I can close out of this. You also can lock the route if you don't want to accidentally make any changes, or if you want to make sure that somebody doesn't change it around, if you send it to a colleague or something like that. You also can show and hide the route if you would like with this button right here, if you have multiple in your data set. There's a handful of other options that you can mess around with in here. We don't need any of them right now, but UgCS has a really good YouTube page, as well as on their website they have a bunch of tutorials and articles and things like that going through a bunch of these different options. So if you want to learn more, you can go to use those resources. When you're happy with all of this, you want to click Menu and then Export Mission, and then give it a name and then Save. I'm not going to do that today, but that is the essentials of getting started with flight planning.